Example 2, we've got shifting, but this time it's shifting up and down. So we are once again going to be looking at a table of values just to give us a bit of a hand, and then we'll go from there. So what we've got is the graph of y equals 2 to the power of x is shifted down 2 units. So what we've got to look at now is what is the equation of the shifted graph. So if we've got y equals 2 to the power of x and we shift it down 2 units, we're going to have y equals 2 to the power of x minus 2, because we know that the minus 2 will just shift it down. It is a translation. Construct a table of values and sketch it. So we're going to start minus 2, minus 1, 0, 1, and 2. They're nice and easy. You would then substitute those numbers in. We've done this before. Anything to the power of 0 is 1. And then if you had 2 to the power of 1, that is 2. So obviously the first one we're doing is that. So that would be 2, that would be 4. And if we go back this way, we'd have 2 to the minus 1, which is half. And then we have a quarter if we substitute them in. All right. Now what we're going to do is we're going to substitute into the new equation, the shifted graph. So we're doing exactly the same, but minus 2. So funnily enough, so we would have minus 1, we would have 0, we would have 2, minus 3 on 2, and minus 5 on 2. So, or minus 1 3/4. Quarters. Minus 3 on 2, and quarters. So minus 1 3/4 we'll do, and we'll go minus 1.5 on there. All right. Then you sketch the two graphs. So we'll go back to red. We've got our points, so x is 0 and 1. Minus 1 is a half, minus 2 is a quarter. We've got 1, 2, and then 2, 4. It is an exponential graph, so we are expecting it to do that sort of thing. If we then did the blue one, you should recognize that it is basically exactly the same, except our horizontal asymptote now is at minus 2. So we go through 0, minus 1, and then we go through 1, 0, and 2, 2. So ours will look a lot more like, oops, that's a terrible graph, like that. And they do sort of approach each other, but they're not going to touch them. So that's graphing them. Then we've got question C, state the asymptotes of the two graphs and their domain and ranges. So question C, let's have a look at y equals 2 to the power of x. The asymptote, so remember the asymptote is just where the graph does not exist. That is at y equals 0. We cannot get to y equals 0 because as we head back towards the negatives, we're going to get a larger denominator, which just means we're getting close to 0 but never getting there. Then the domain, can't scroll, that's annoying. Domain is, and then it does it all by itself. The domain is all real x, and the range, get rid of them. The range is y is greater than 0. Well, we can't get a negative. You can see that we're going to get smaller and smaller fractions, but we're never going to get to negative. With the next one, we've got 2 to the power of x minus 2. The asymptote is y equals minus 2. We've already looked at that, and I've already drawn the dotted line. Our domain doesn't change. It is still all real x. But for this one, the range, we have shifted it down to, so we're still going to have y is greater than, but this time it's going to be greater than minus 2, because that's what we've shifted. All right. Done skis.